Okay, so today I'm going to talk about circular motion. So what is circular motion? So in circular motion, there's always an acceleration that points to the center of the circle defined by the object's motion. This force changes the direction of the velocity vector of an object, but not the speed, which means that the speed doesn't change, but the direction changes. So like when there's a satellite here, it's always moving at a constant speed, but there is acceleration pointing to the center because that the direction is changing. And remember that velocity is a vector quantity. And what is circular motion? So now you can see that this animation. So at first you can see here this is speed, velocity toward here. Velocity, like that. So when this turns from here to here, and if you move it to here, you will find this red part is the change in velocity, or you can say maybe it's the acceleration. And if you move it back to here, and you will find that this acceleration points to the center of a circle. So what is centripetal acceleration, which is the acceleration? And centripetal means point to the center, like in this picture. Like when the velocity goes here, and the acceleration goes here, so it changes the direction, allowing it to become here, here, like that. And so now I have to ask you a question. Can an object accelerate if it's moving with a constant speed? Oh yeah, many people find counterintuitive aspect first because they forget the change in direction of the motion of an object, even if the object is maintaining a constant speed, still counts as acceleration. So that means that even though the speed is the same, but the velocity changes because the direction changes. So that's why there's acceleration. So if the velocity changes, there will be acceleration. So now I have to see there is a formula. So AC means the centripetal acceleration, or the acceleration equals to the velocity squared divided by r. Okay? And why? So now I'm going to prove it. So how? So now you can see at this picture over here. So if delta okay, so now you can see delta V. So this is V2 right here. Hence V1. So if you move it to here and move this to here, you will find this part is delta V. So this is the change in velocity. And this is R, the radius. This is radius 2. This is delta R. Right? And now when this angle, this delta theta, is very small, close to 0, and you will find that delta S is almost equals to delta R, which means that this part can just be delta S. Okay? And you will also find something. That the triangle PQR is similar to the ABC, triangle ABC, which means that the delta S divided by R, which is this part, divided by here, and this is delta S divided by delta R equals to this delta V divided by V. Delta V divided by V. Okay, so then you will get this conclusion that you'll get the conclusion that delta V divided by V equal to delta S divided by R. And you move this V to here, you find delta V equal to V divided by R times delta S. And divide by both sides by T, you'll get this equation. And you will find delta V divided by delta T is called the acceleration, which is the centripetal acceleration, AC, equals to V divided by R, while delta S, which is the delta S, divided by delta T, which is just equals to that V. velocity, which means that AC is equal to V squared divided by R. Then we can prove it. And now we have an example, curving car. So what is the magnitude of a centripetal acceleration of a car following when a curve is seen in a figure below? A radius of 500 meters at speed of 25 meters per second, about 90 kilometers per hour. So first remember is we are going to calculate AC, centripetal acceleration, equals to V squared divided by R. And now we know what's the V. Well, the V is 25. So 25 squared divided by the radius is 500. Okay. So this is okay. So and then you'll get 625 divided by 500 equal to 1.25 meters per second square. Okay, so see, correct answer. And another example. Okay, so calculate. So this is just a machine that will spin very fast. Okay. Okay. So calculate the centripetal acceleration of a 7.5 centimeters from axis of an ultracentrifuge. Okay. And spinning at 7.5 times 10 to the 4th power RPM, revolutions per minute. Okay. So first, remember, AC equal to V squared divided by R. And now we already know the R, but remember we calculate in meters. So we have to convert it into 0.075 meters. And the velocity, now we have this. So we can calculate the velocity, or a velocity. So now first you can see something. What? So you can see that this is like a frequency, right? And the velocity equals to 2 pi r times frequency. Equals to 6.28 times 0.075 times 7.5 times 10 to the 4th power. But remember, we use RPS, revolution per second. So we have to divide it by 60. So it's also equals to 9. I'm going to open my calculator. This one. Okay. So 6.25, really? No, 6.28. So it's okay. 6.28 times 0.075 and times 7.5 times 7.5 times 10 to the 4th power 7 divided by 60. So this number, so this number is about 589. So I will just use 589. 9, okay? And now 589 squared divided by 0.075. So where's my calculator? Okay. Oh, 589 squared divided by 0.075. Oh my god. 589 squared divided by 0.075. Yes. So it's about this. So 6462613. So it's about 4.4 4.63 times 10 to the 1, 2, 3, 4, 5, 6. 6 power. So which is 589 squared, which is about 4.663 times 10 to the 6th power. And let me check the answer. Yes, correct. Okay, so next question. So what is omega? So this is called omega. Okay? So omega is called the angular velocity. So it's defined as delta theta divided by delta t. So sometimes we can use degree divided by second. But now we use rad divided by second, right? Divided by second. Okay? So this is 360 degrees. It's defined as 2 pi. Okay? So for one perfect circle, 460 degrees for one spring, it is 2 pi 460 degrees divided by the time. And the time is the period, which is the t. And also equal to 2 pi f, and also equal to v divided by r. Okay? Because omega equals to 2 pi f, while velocity equal to 2 pi f times r. So v equal to r omega. So example 1. An object doing circular motion, and we can know that it is 10 RPS, and the radius is 0.1 meters. And what is the angular velocity per second? Okay. So now it's very simple. So because the omega has nothing to do with radius, because when you see it is equal to 2 pi f, and this will be divided by r, and it has nothing to do with radius. So even though that v has something to do with radius, but it's divided by the radius, so it has nothing to do with radius. And remember, we just said it is equals to 2 pi f, and this is pi, okay? And this is actually the frequency. It is equals to hertz. So this is actually equal to 20 pi, which is the D. Is the correct answer. So D. Let me see the answer. Yeah, D. Okay. So now AC equal to omega squared r. Let's prove it again. So because now we already know that AC equal to V squared divided by R. AC equals to V squared divided by R. No. I said R. Okay. So now I'm going to find that AC equal to V squared divided by R. Well, what is V? V equals to R omega. And you put this V inside, you will get that AC equal to omega squared R. And while omega is also equal to 2 pi divided by T equals to 2 pi F. And you put it inside, and you will get this equals to 4 pi square R divided by T squared. Okay? Also equal to 4 pi square R F squared. Okay? And next. Okay? So what is FC? FC is a centripetal force, not centripetal acceleration. But what is centripetal force? So it's the force toward the center, because we know whenever there's acceleration, there's force, right? And because F equals to M, wait. Okay, so because F equals to MA, FC equals to M times AC. So you can see all the formula. V squared over omega squared are 4 pi squared 4 pi squared r divided by t squared, 4 pi squared r f squared, just all times by m. You will get FC, so this is a V, so there's FC, this is, because there's AC, so there's FC. This is a force towards the center, called centripetal force. And here's an example. A radius object have a radius of r during circular motion, and the kinetic energy K is K, and K equal to this a hint. And the centripetal, what is the centripetal equals to? So what is the centripetal force? The number of centripetal force. So remember, if you want to know Fc equals to m times AC, right? So you can just directly use this formula. Or you can first calculate AC and times it by m. So what's the AC? First you have to know. Because AC equal to V squared divided by R. You know it. Because this is equal to mv squared divided by R times. Okay? So V squared, you can see V squared, now we know K. So since K equal to 1/2 mv squared, so we can find that V squared equals to 2K divided by M. And now we just put it in. So AC equal to 2K divided by M, like that, R, okay. And now if you want to change it into FC, you have to times it by M, and M cancel, so it's equal to 2K divided by R. So the answer is B. Okay, this is actually capitalized R. Okay. So you can see the answer is B. Yes, it's B. And another example 2, so there's 2 points, and their speed are both V, and while they're, for this one, this point, this max, the radius is A, for this one, the radius B, and they're moving one toward the X, one towards the Y, like that, so moving, and what is their relative acceleration? Okay. So first, AC for the first one equal to V squared divided by R equal to V squared divided by A. While the centripetal acceleration for the next one equal to V squared divided by R2 equal to V squared divided by B. Right? While AC this, okay, equals the relative acceleration equals to AC squared plus AC squared, because they are vertical, they are perpendicular. No, they are, yes, perpendicular, which is equals to A squared B plus B squared square root, which is equal to, this is called A B squared A squared plus B squared, and this is the A, so the answer should be A. Yes, it is A. And example 3, I think it's the last one. Yes, it's the last one. Okay. So let me see, now there is string, and this name is L, and it's doing circular motions. And the mass is m, like that. It's omega. The omega is equal to omega. Okay. And this is theta. And what is what is cosine theta? What's the number of cosine theta? So first, you have to analyze the force. So let me change into green. First, when you see this picture, okay, here it gets mg down, and this gets t. This gets this, okay, got only two force, and together, so it got only two force, but together they get this called centripetal force. And while this number is theta, while FC equals to mg tangent theta. Okay, so in other words, that means AC equal to G tangent theta. Okay, so AC equal to G tangent theta, and it is also equal to, remember that AC equal to omega squared R, right? So it is omega squared, while the radius, that's important. Why? So now erase it. And what is the radius? So if you look carefully, the radius is not L, not equal to L, because the radius is toward the center right here. So this part, this is the radius. So this is called sine theta. Okay, L sine theta actually. Okay, and then you will find something interesting. It's getting cosine, right? And sine divided by cosine equals to sine divided by tangent equals to cosine. So now you move this to here and move the L and omega to here. You will find that G divided by omega square L equals to cosine theta. And then we got the answer, which is G divided by blah, blah, blah. Okay, answer is B. Okay, so thank you very much. This is the last question, and I made this hard actually. So remember something. What? So it's copyright. Wait a minute. So remember, this is copyrighted by me. So now you can see where. Okay, I won't erase it. Okay. So remember, this thing is copyrighted by me. Thank you very much. Bye bye.